It will be C multiplied by V. Correct. Okay, Josefa, tell me what will be the energy? How do we calculate the energy? Krishna, how do we calculate the energy?
Q square by 2C equivalent.
Q square by 2C equivalent. Q square divided by 2 times Cn. Okay, Fatma, corrected. Yes, Fatma, you were saying something about your examination.
Yes, teacher, I have my examination day after tomorrow.
Day after tomorrow. So it's on Thursday.
Yeah.
And the chapters are included, first and second completely,
Yes, teacher.
along with the third one.
Third one only till Ohm's law.
Okay, only till Ohm's law. Okay, Fatma. So see, second chapter up till today, we are completing the second chapter only. The combination of series and parallel is there. So first and second are done. Regarding the third one, we can have a class of 1 hour, so we can complete it till Ohm's law.
Okay, teacher, thank you.
So we had seen individual circuits. Individual circuits we had seen. Now let us see combinations of circuit. If combinations of circuits are given to you. Now see, you can have different combinations of circuit. Various circuits must be there, and you should identify among them. Whether it is in series, whether it is in parallel, that's up to you. You have to identify. If you're not able to identify whether it is in series or it is connected in parallel, best way is through charge. Look at the charge. So with the help of a question only, we'll be doing it. Let me give you a question. So let's say all the capacitance are C, identical capacitors. This is also C, this is also C, C, C. But let me add one more. In this branch also, let me add one more capacitor over here, whose capacitance is also C. Now this is a combination where you have series capacitance as well, capacitors connected in parallel. You have all the different capacitors connected. Fine. So now you have to find out the equivalent, calculate C equivalent across A and B. Now see, how do we solve such kinds of questions? See, let's name these capacitors. Let's start naming from it. This is 1, this is 2, this is 3, this is 4th one, this is 5th one, this is 6th one. All of the capacitors are identical. Now you have to identify among them how to begin. Which one is in series, which one is connected in parallel. So see, if you look at both of these, there's a branching. If you remember, I have discussed it with you. Whenever there is a branching, charge gets divided, but branching does not affect your voltage. And if you have voltage with you, capacitor is connected or any device is connected, be it capacitor, be it inductor, be it resistor. So in this chapter, we have only capacitors connected. So if capacitors are there connected, then potential will change, but it won't affect your charge. So see, you can easily see, if you look at these two capacitors, just these two capacitors, you can see what? Here's a branching. It means both of them are connected in which way?
Parallel.
Parallel connection is there, because definitely charge will get divided, but whatever voltage is there, that will remain the same. And this kind of question we have done in the last class also. In the last class, we had seen a combination as well. One combination we have already discussed. So see, these two are connected in parallel. So C1 and C2, These are connected in what manner? These are connected in parallel. Now see, C12 means C equivalent of both of these. C equivalent for parallel capacitors. Parallel capacitors means capacitors connected in parallel combination. Equivalent is given by just simply adding them. So this will be what? Capacitance of one is what? C. Capacitance of other is what? C. So C plus C, that gives you 2C. So this has been reduced. So let me redraw the circuit, how the circuit now looks like. After this combination, the circuit now looks in this manner. This was the fifth capacitor connected with the fourth capacitor and the sixth capacitor. These have not been affected, which were there in the extremity. These have not been affected yet. Then we had the third one. Then there was a third capacitor over here. Now, regarding the first and second, these have been clubbed together. We have got a single capacitor. We have taken out the equivalent capacitance. So now we no more have C1 and C2. What do we have now? We have C equivalent of first and second. That is what I've named as C12. So instead of both of them, I'm writing a single capacitor instead of 1 and 2. That is, this is my C12. This is C12. Means initially it was what? This was connected with C1 and C2. Now this is what? This is only C12. Means I have reduced C1 and C2. I have taken the equivalent capacitance of both of them. Now this value is C. This value is C. This value is C. This value is C. But C12, this is 2C now. This is my equivalent circuit now. Now I have to solve it further. I have still not reached the end. Now, if you look over here, now you have these two circuits across your way. Both of them are connected by a single wire. Will the charge divide or the capacitor will divide the voltage?
Voltage.
Voltage will get divided. So if your voltage gets divided, it means what? Your charge is same. So are they connected in series or are they connected in parallel?
Series.
Series. Reason? See, all those who are not able to identify whether they are connected in series or they are connected in parallel, just look at it. This is a single wire. If I take this wire and the charge flowing is 2 coulomb, even I bend this wire, that similar charge 2 coulomb will only be flowing. So it means this is now connected in series. So C12 and C3, these are now connected in series. C12 and C3, these are now connected in series. Now equivalent capacitance, 1 by C equivalent is written in which manner? 1 by C3 plus 1 by C12. I have to take out the equivalent capacitance of both of them. So how should I write it? 1 by C equivalent will give me C3 is C, C12 was 2C. So this is it. Now if I take the LCM of 1 by C equivalent, this becomes 2C. I have to multiply this by 2 plus 1. So C equivalent is coming out to what? 2C divided by 3. First tell me, till here is it clear?
Yes, ma'am.
Anyone who is facing difficulties, how to identify in series or in parallel? We'll see different methods. Kulsum, are you able to identify? Are you able to understand, Kulsum? I think you missed your classes.
Yes, ma'am. I'll catch up.
Okay. So if you are having any doubts, Kulsum, let me know. I'll repeat the topic. All right.
Thank you.
So now see, I have what? I have this reduced. This circuit has been reduced further. See, when you will be solving it yourself, it won't take so much time because you'll solve it quickly. Now I'm reducing this circuit once again. I'm reducing the circuit that I've drawn once again. So this is the first capacitor. This was the fifth capacitor. This is the fourth. Here we had the sixth capacitor. They are connected with the fourth capacitor. And the sequent is actually what? The sequent is C123. Let's name it as C123. This will be easier for us to remember what all combinations have been made. So this is C123. So C123 is now connected over here. Instead of C3, we have C123. Reason? First we clubbed C1 and C2. Then we clubbed C12 with C3. So we got C123. Now we have to check for the, this is, all these are CC and this is 2C divided by 3. Now, this combination again, if you look at this combination, all of you write me in the chat box, what are you able to see? Which combination is this? Series or parallel? Write in the chat box, all of you. Only 4 students have answered, Krishna, Atif, Fatima and Akifa. Okay, Hanifa, Fatima, Kulsum. Hamza, you tell us. Okay, Hamza has also answered. Fine, yes, correct. It's parallel combination. As you can see, here's branching. Obviously, charge will get divided. We cannot have it in series. This also looks even like parallel. This is a very common example and typical circuit of parallel combination. No. So this is connected in parallel. So C1, 2, 3, 4 means this whole combination. These are connected in parallel. So this will be what? 2C by 3 plus C. Means you add them in parallel. No. So C1, 2, 3, 4. I'm writing C1, 2, 3, 4 so that you are able to remember which all combinations have been made. So this will be what? This is divided by 3. If you take the LCM, so this becomes multiplied by 3. This is 5C divided by 3. This is your C1, 2, 3, 4. Now, if I draw the circuit again, this is the circuit. Now, this is C1, 2, 3, 4. This is fifth one. This is sixth one with capacitance CC. This has capacitance what? 5C by 3. This is point A. This is point B. Now, look at all of them. See, this is a single wire left now. You don't have any branching. You have no other circuit attached. This is a single wire. So, all these three, if you look, all these three are connected in series. Correct, Fatma. All these are connected in series. See, this is a single wire where 3 capacitors have been attached. So voltage will keep on dividing. The single charge will run across them. So now sequent will be what? Equivalent of the whole combination. These are connected in series. So 1 by sequent will be 1 by C5 plus 1 by C6 plus 1 by C1, 2, 3, 4. This will be your resultant because reason C5, C6, C1, 2, 3, 4, all these are connected now in series. So 1 by C equivalent will be what? This is 1 by C plus 1 by C plus that was 3 by 5C. So take the LCM as 5C. This will be 5 plus 5 plus 3. This becomes 10 plus 3, that is 13 by 5C. So your C equivalent is 5C divided by 30. This is your whole capacitance for the full circuit. So in this manner, you can start with it. Take the whole circuit, identify areas where it can be reduced. Means you can identify parallel or series. We had seen C1 and C2 were connected in parallel. Then C1, 2 was connected with series in C3. Then their resultant was connected in parallel. And finally, we got a single circuit, say we connected by a single wire, which were connected in series. All right, so start writing this down. If you have any doubts, you can ask me. Now see, many times what happens, series and parallel circuits are very difficult to identify. You won't be able to identify whether same charge is flowing or whether they are having the same potential. So you have one more method, potential divider method, and some questions are set based on this potential divider method, and those questions only come. So potential divider method means what? I'll give you an example. For example, 3 capacitors are connected. All right. Now a wire has been added in this manner and another wire has been added in this manner. This is the typical question that usually comes in your exam. Let's say C, 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 these are the capacitance of this. This is point A, this is point B. Now, the same wire will be having the same voltage. So transmit all the voltages across the same wire. See how? Look at this. This is A wire, means potential. Let's say this potential is VA. Now start moving through this wire. Just start tracing it. So if you will trace it, you will reach here, end of the wire. But this is the same wire, no? There's a branching has been done. So voltage will be the same. Branching does not affect your potential. So it means you can have the same voltage across this wire also. Start moving along it. Now start moving, just trace it. You have reached this end and you have reached this end. Now capacitors are there. Now after the end of these wire, now capacitors are there. It means your voltage will now divide. Till here you are having the same voltage. Whatever voltages are there, quickly name it. Let's say the voltages, this was VA. This was VA, so it will be VA till here. We have moved. It will be VA. It will be VA. Till here it's clear. We have just identified all the VA where the same potential could have run. Now, let's talk about the second wire that we have, B point that you have. Now, if you start moving across this B point, capacitor has come, we cannot move further. Why? Voltage will get divided. We are just focusing on potential. Don't look at the charges. Charges will confuse you more. So this we have reached end. Now we are crossing this wire. Just trace this wire. You have reached this end. Now capacitors have reached. It means now the potential will be different across it. Now name it. If this was B point, so this will be VB. This will be VB. This will be VB. So you have all the potential differences across the capacitors. What you have done, you have just traced yourself across the capacitors. Now, a method how to identify this you have done. You have used potential divider method. Now, how to identify whether they are connected in series or they are connected in parallel. See how to identify. How many potentials are there? 2 potentials are there, VA and VB. 2 potentials you are able to identify. 2 potentials are there. Now, make them point. Make the point VA, make the point VB. And what all capacitors are coming in between these? No, just add them. For example, if we talk about the first capacitor, if I talk about this first capacitor, it is coming between VA and VB. Put it. This is coming between VA and VB. See. Look at the second one. It is coming between VB and VA. VB and VA. Add it between VB and VA. See. The last one. This is also coming between VA and VB. Join it with VB and VB. If you redraw it properly, you will see that it is nothing but a combination of 3 capacitors connected in parallel. So it means this whole circuit, this manner, this was connected in parallel. Yes, Fatma, it is connected in parallel. So C, these are given. So if this circuit was given to you, 3 capacitors connected in this manner, and equivalent capacitance was asked, simply the answer would be 3C. Reason, you have to add all the capacitors. This way you will calculate. No. C. You just have to identify whether they are connected in series or parallel. Now, you can get sometimes confused with this wire. So you have a case which is called as the short circuit. Now, understand what is meant by a short circuit. You must have used this term in your daily life. Circuit has been shorted right now. So what happens if this is a bulb, this is connected to a cell, and you have added a wire in this manner? So what happens? All the charges that flow across this, instead of passing through the bulb, no, they pass through this wire and then come back. So bulb does not receive any charge, and this is valid for current also. So in the next class, we'll be starting with current electricity. So the same terms will be used: short circuit, open circuit. In case of short circuit, all the current will flow through the wire, the additional wire that you have. But within the bulb, there is no charge receiving. The bulb is not receiving charge. The bulb is not receiving any current. So will the bulb glow or not if it is not receiving any charge?
No.
No, it won't receive. So it means, is the bulb of any use to me if I do not draw the bulb? If I draw my circuit in this manner, with the charge Q flowing, both of them are equivalent, I can draw the circuit. So it means if there is a case wherever short circuit has been done, means any circuit has been shorted with the addition of a single wire, just replace it with a single wire. For example, if you have capacitors and wire, there has been a wire, additional wire. So no charge will flow the capacitor. All the principles and the working and the processes of a capacitor will cease up. So you can draw a single wire. If you have a resistor, which we'll study in the next class, and if a wire has been drawn, you can write it as a plain wire. Reason, there's no functioning of it. Neither the resistor, nor the capacitor, not even the bulb. All right, let me give you an example where short circuit, where you have to identify between short circuit and you have to identify between or use or put the application of potential divider method. Supposedly there are, let's say, 5 capacitors are there. All right, let me name them. 1, 2, 3, 4, 5 capacitors are there. One wire in this manner, other wire in this manner, one wire in this manner, and leave this. So all of them are having the capacitance C. All of you write me right now. Do you see any capacitor that has been shorted, or do you think no, none of the capacitors have been shorted? If you see any capacitor, if you see any short circuit, just name the capacitor. Fatima, Akifa, Atif, Hanifa. Okay, Hanifa, give me the reason. Why do you think the 5th capacitor has been short? 5th capacitor, you say, no, the 5th capacitor. Why has been it short circuited? Okay. See, anyone else? Can anyone else correct her? Okay, Atif, you correct her. Yes, Atif?
Actually, you called me. I had some issues. Can you repeat what you asked?
You have answered me correctly. Just announce the answer. Which circuit has been short circuited?
Oh, yes, the 4th capacitor.
Fourth
C4
capacitor, C4 capacitor. See, Hanifa and others also. In case of 4th capacitor, what is there? This is the capacitor and a wire has been added. So it means all the charges will flow across this. No charge will flow across the 4th one. So it means 4th capacitor is of no use. See, Hanifa, you have to identify this one in this manner. Wherever you see such a circuit, then you say it has been short circuited. Hanifa, is it clear now?
Yes.
All right. So in this case, what will happen? Fourth one has been short circuited. So this is of no use. Even if you draw single wire instead of this capacitor, the answer will be the same. Now, what about the other portions? Let's revise it. Let's say this is first wire. Till here we have stopped. Let's cross this wire. So we have reached this end. All right, now we have blocked all the capacitors. It means no more capacitors can be added. So let's name all the potential. This is VA, this is VA, this is VA. Now VA is this much only. If you look at this capacitor, let's say this is some C voltage, because B is still here only. Let's see, this is, so let's keep on moving along with it. You have reached this end. So this is not there. Fourth one is not there. Till here you have reached. So name all the potentials that are there. This is, let's say, VC. This is some potential VC. This is VC. This is VC. This is of no use. All right. Okay. So these are all the possible. Then this is B. This one is B. So what will we name it as? We will name this as VB. Regarding this, see, there is no circuit over here. We have drawn a single wire instead of it. We have drawn a single wire. It means there is a single wire instead of C4. So this point will also be having VC, same voltage. This will be VC. C4 has been eradicated because there is of no use. C4 is of no use. Now let's redraw the circuit. The manner how to reconstruct the circuit. Now we have 3 voltages. Write down all the 3 voltages. VA, VB, VC. Now you have 3. Earlier you had 2 only. C4, you have replaced it with a single wire because it has been short circuited. First capacitor, it is coming between A and C. Let me exchange it. This is C, this is B. All right, so this is coming between A and C. I have drawn it. This is coming between A and C. Then this is also coming between A and C. This is also coming between A and C. This is also coming between A and C. In this manner. And this is no capacitor right now. You have a single straight wire. This is instead of C4. And you have this between C and B. So this is C and B. This is C. This is what your circuit is actually. Now if you see, these are connected in which manner? All these 3 are connected in parallel. These 3 are connected in parallel. So they are having, this can be reduced to a single capacitor of 3C capacitance, because C plus C plus C will give you 3C with addition C. So you have to find between A and B. So 3C and C are connected in series. So 3C and C, these are connected in series. So C equivalent will be what? 1 by C equivalent will be 1 by 3C plus 1 by C. That gives you 3C. So this is 1 plus 3. So equivalent capacitance is 3C divided by 4. In this manner, you have to calculate if different capacitors are given to you like this. Clear? Any doubts till now? Okay, do one thing, start noting down this potential divider method. If you're not able to identify why have we written VA, why have we written VB or VC, whatever, just ask me. Or you are uncomfortable in unmuting yourself, text me. I'll repeat it. So start noting, see if you get stuck. Try to first solve yourself. Trace it, see which potential where the barrier of capacitor is coming.
Ma'am, could you explain this potential divider method again?
Okay, see Krishna. Along the same wire, just keep on moving till you see the capacitor. Fine. So we had started moving. We had seen a capacitor, we stopped. It means this is VA. Now, since it is having one more branch, it will also be having the same potential. So VA came till here, VA came till here. Just understand this one. The lower portion one is easier than this. So VA we have written. Till here, is it clear?
Yes, ma'am.
All right. Now we look at this point B. It will be having potential B. Reason why are we adding potential? Because this is a circuit. It means this must be connected to some potential difference like this, whose potential this was VA, this was VB. That's why we are writing VA all over. Since this is of no use, we are not calculating potential right now. We are not calculating total charge. That's why I have not drawn this lower portion. But the terminals have been connected to the cell. Now, regarding this point, will also be having a voltage. Start moving. We will reach an end of a capacitor. So we have stopped. It means this is VB. Beyond, if we go through the capacitor, potential will get changed. And you can see also potential is different. That is VA. Now start moving. These two ends have reached. You have reached a capacitor. Now what you have seen, you have named it as VB. Is it clear till here? Why are we naming it as V and VB?
Yes, ma'am.
All right. Now see, whatever points you have, A, B, C, D, even if you have more number of capacitors, do one thing, write down all the points in order to identify. So what happens whenever potential are same, capacitors are connected in parallel. Reason is this. So what you do, write VA, write VB, and all the capacitors that are coming in between these 2 points, put them. So if you put them, they will come in starting from V and VB, all the 3 capacitors are coming together. Now, if you look at this, all the potentials are same. The difference is what? Potential difference is VA minus VB. Potential difference is VA minus VB. Potential difference is VA minus VB. It means all of 3 are connected in which manner? All those 3 are connected in parallel combination. So you can directly redraw it in this manner. The lower one, the next one which we had discussed was similar to it. Difference was that firstly it has been short circuited, so one capacitor has been reduced. That is your work only. Regarding the 5th capacitor, it has the potential difference VC minus VB. All the 3 are having the potential difference VA minus VC. It means all the 3 are connected in parallel, but since the potential difference is same for the 5th one, this is connected in series. So this is also a method you can use by checking the potential difference. Now clear?
Yes, ma'am.
All right, so one more method let's discuss. Actually, we have 3 more methods left, but 2 of them are very important use of yours. But this one which I'm discussing, this doesn't come usually in your capacitors. This usually comes with your resistors. You have a setup which you call as Wheatstone bridge. So Wheatstone bridge, this is this. If you see capacitors connected in this manner. So maximum time questions come from this portion, Wheatstone bridge, with reference to resistors, if you have resistors connected in this manner. So in current electricity, we will see it again. We'll see this again, but if it comes, if you see such a connection, then this is called as the Wheatstone bridge. With some EMF is connected. Let's say this is C1, this is C2, this is C3, this is C4, this is C5. This is your point A, this is point B, this point is C, this point is D. Now, under balanced condition, when do you call it a balancing condition? Is if you take out their ratios and equate them. For example, C1 divided by C2, this is equal to C3 divided by C4. This is a balancing condition. So if the question says this is a balanced Wheatstone bridge, find out the other one. This is a balanced Wheatstone bridge, find out C2. For example, C1, C3, C4 have been given to you. The question says that it is a balanced Wheatstone bridge. So use this, take out the ratio, find out C2, whatever unknown is there. Or it can happen to check whether it is balanced or not. So to check whether this is a balanced or unbalanced Wheatstone bridge, you just have to look at this balancing condition. If the ratios are coming equal, for example, 5 by 10 is there and 2 by 4 is there. So 5 by 10 and 2 by 4, if you write, both of them are equal. So in this manner, if you see, both of them are half-half. So if you see such a condition, both of them are equal, C1 by C2 and C3 by C4. You call it a balanced condition. What of your use is that the potential difference between these opposite ends, this is 0. VB becomes equal to VD if the bridge is balanced. This is only possible if the bridge is balanced. So if your bridge is balanced, VB becomes equal to VD. So if VB becomes equal to VD, there is no potential difference across it because VB minus VD, this becomes 0. So if there is no potential difference across it, no current even flows through this. You can easily remove this if it's a balanced Wheatstone bridge. If you see such a condition, you have to first identify whether it is balanced or unbalanced. So potential difference across C5 will also be 0. Potential difference across this C5 will also be 0. So see, if there is no charge flowing through this wire, then remove this wire. So what you can see, C1 and C2 will get connected in series and C3 and C4 will connected in series and their resultant will get connected in parallel. So Wheatstone bridge we'll see in detail when we'll reach the next chapter. So this is the last class only. From the next class, we'll start with the next chapter only. There we'll see Wheatstone bridge in detail. But the next method that I am going to tell you, that is very important. First, do one thing, note down the Wheatstone bridge portion. Then we'll do the plate method. Just text me when you are done. So most of you have completed it. If anybody is writing, just stop me. Otherwise, let's start this problems involving plate. This is an important method. Wheatstone bridge for this chapter is not that important, but problems involving plate, this is important. This has come a lot of time in your CBSE questions as well as in your entrances, especially in NEET previous years. This question is there. And in JEE also, in your entrances also. See, I'll start with an example only. If these are parallel plates connected, these are also plates connected in this manner. This is, let's say, X end, this is Y end. Now, if I connect both of these ends to a wire, to a cell, so one will develop positive charge, other plate will develop negative charge. Reason? One terminal is positive, other terminal is negative. So battery EMF cell, that we'll see in detail, but right now you should understand that if this is connected to positive terminal, let's say, so this whole plate will become positively charged. This whole plate, this will become what? Positively charged. And what about the other plate? Other plate will develop negative charge. Negative charges, this plate will develop negative charges. In this manner, this whole plate will develop negative charges. Now you have to identify whether they are making a capacitor or not. All these are connected in parallel because they are connected to the same voltage. So that is different. First, identify whether a capacitor has been formed or not. If you are able to identify a capacitor or not. See, in the beginning only, when we started with capacitance, we had seen capacitor is what? Any conductor. If you have two conductors or if you have two plates with you and you make them oppositely charged somehow, one is positively charged, other one is negatively charged, then you call that combination as a capacitor. This was what we had seen. Then different capacitors were there: parallel plate capacitors, spherical capacitors, cylindrical capacitors, out of which spherical and parallel we have discussed. So these are actually forming a parallel plate capacitor. Now, if you see, this is a positive plate, this plate, one plate, and this second plate, this is a negative plate. It means this can form your capacitor. Let's say the separation is G. Let's see this plate, this third plate and this fourth plate. This is negative, this is positive. This can form your capacitor. Then look at this fifth plate, look at this sixth plate. This positive side of fifth plate and the negative side of sixth plate. This can again form your capacitor, separation T. So three capacitors we have found from these two plates that were connected in this manner. Three capacitors we are able to identify. Three capacitors we are able to identify among these plates. Now all of these are connected in parallel. If you see, they are connected with the same polarity, no, to a single cell. This setup is always, this is connected in parallel combination only. But main thing is not parallel or series here. Here you have to identify whether a capacitor is getting formed or not. See, in this manner, what will happen? Three capacitors are there which are connected in parallel combination in this manner. In this. So what is the parallel plate capacitance? If air is the medium, Josefa, if air is the medium, what is the capacitance of two parallel plates? We had seen four cases. This was the first case. Then we had seen if a dielectric slab has been inserted, if dielectric slab has been partially inserted, if a conductor has been inserted. Any idea, Josefa? Yes or no, at least? Okay, Josefa. C. Anyone else?
C is equal to epsilon naught A by D.
Epsilon naught A by D. Josefa, are you now able to recall? We had done this. C is equal to epsilon naught A by D. This is the capacitance between two parallel plates. If a dielectric slab is inserted, then you multiply it with K. If a dielectric slab is inserted, which is partially filled, all right, Josefa, then you put the denominator as D minus T plus T by K, which is the thickness of And if it's a conducting slab partially filled, then we write only D minus T. So these were the cases that we had seen. Now C is equal to epsilon naught A by D. This is the capacitance of it. Capacitance of single capacitor is epsilon naught A by D. No, here you have how many capacitors? Here you have 3 capacitors connected in parallel. Resultant capacitance is given in which manner? C plus C plus C. So directly you can write it as C equivalent will be 3 times C, which is 3 times epsilon naught A by D. In this manner, you have to identify whether they are connected in series, whether they are connected in parallel. Your prime concern is what? First, to identify how many capacitors are made. See, always 3 capacitors won't get formed. Let me give you another example. Let's do one more example, then only this portion will get clear. If I give you 2 capacitors in this manner, 2 plates in this manner, this is the first plate and this is the second. Now let's say this is point X, now let's say this is point Y. So the positive terminal, this plate will become completely positively charged. If this plate is connected to positive terminal of battery, then this whole plate will become positively charged. This plate has become positively charged. Now the other plate that we have, this plate, this will develop negative charge. Reason? Because this plate has been connected to the negative terminal of the battery in this manner. Now we have to identify capacitors. See, this is plate 1, this is plate 2, 3, 4, 5, 6. If you see such a case, no, they are connected in parallel always. We see according to polarity. If they are connected with the same polarity, we call them they are connected in parallel. And if they are connected with the opposite polarity, we call it in series. So they are connected in parallel only. Prime concern is what? To identify whether it's a capacitor or not. This plate, one plate is positively charged, plate 2 is negatively charged. It means we have a capacitor. Let's say separation is 10. Plate 3 and 4. Does it form a capacitor? Is it forming a capacitor?
No,
It's not forming a capacitor. Reason, Fatima?
because both are negative.
Both are negative. And you cannot have a capacitor with the same polarity. Both plates, if both the plates are negative, then it means it's not a capacitor. Condition for capacitor is that one has to be negative, other one is positive. That is, we have always seen this case. It means there's no capacitor over here. Now, if you see this negative plate and positive plate, this is forming a capacitor. So now C equivalent will be what? 2 times C.
See,
Because 2 capacitors are there. So equivalent will be 2 epsilon naught A by in this manner. So it can happen there. You can have a situation where both the plates are having the same polarity. So there you have to identify is the capacitor forming or not. All right, so note down these points also. Then we'll see one last case. If a dielectric slab gets introduced. So prepare your chapter 1 and chapter 2 completely. Electric charges and field and electric potential and capacitance. Now a dielectric slab, if it gets introduced. So there are two methods you have to identify. If dielectric slab gets filled completely, see, if you see area getting divided, I'll write it down. If you see area getting divided, then they are connected in parallel. If the distance parallel, and if you see the distance between the plates getting divided, then they are connected in series. This is connected in series. For example, if this is a capacitor, the area has been divided by A by 2, A by 2. This separation is the same, capital D. And one end has been filled with a capacitor dielectric constant, and the other has been filled with another dielectric. This is, let's say, K1, this is K2, and this circuit has been connected to wire in this manner, cell. So now see, area is getting divided. It means they are connected in parallel. Both the capacitors are connected in parallel in this manner. So whatever C1, C2 are there, they are connected in this manner. So equivalent will be what? Equivalent will be C1 plus C2. Don't get confused. See, remember all the formulas clearly. When we will be doing resistances, no, in resistances, these same formula will be reversed. For series, if you are having them as C1 plus C1 by C1 plus 1 by C2, no. In case of parallel, it becomes the formula for it. It gets reversed in case of resistors. So be clear about the formula. If it is for parallel combination, this is your formula. So now C1, how do I write C1? It is epsilon naught A by D for air. If dielectric slab completely fills, it becomes K epsilon naught A by D. So C1 is what? K is K1, epsilon naught, area is what? A by 2, then D. This is C1. Similarly, C2 will be what? K2 epsilon naught A by 2D, A by 2, and D is the separation. So add both of them. C equivalent will be what? C equivalent will be K1 epsilon naught A by 2D plus K2 epsilon naught A by 2D. So from here you can do one thing. You can take epsilon naught A by 2D as common, and here K1 plus K2 will be there. This is one method. Now see, how do you identify if the distances are there? Distances are getting divided. See, if this is my capacitor and somehow here two dielectrics have been added. So now in this manner, distances are getting divided, but the whole area of the plate is remaining A still. So let's say this was the first capacitor, the dielectric that you have, and this is the other dielectric that you have. Now in this, what you are able to see, this is K1, this is K2, and this is connected to a circuit in some manner. Now distances are getting divided, means distances between the plate is divided. Equally, unequally, that doesn't matter. Had it been D by 3, your answer would have been something else, but your series connection you would have identified. It's not necessary that it gets divided into half only, A by 2, A by 2, or D by 2, D by 2. It can get divided in any form. So now see, C1 will be what? K1 epsilon naught A by D. Now D is D by 2. So 2 will go up. C2 is what? C2 is K2 epsilon naught A by D. D by 2 is there. So this 2 will go up. Now series combination. How do you write series combination? Take the C equivalent. In this manner, 1 by C equivalent is 1 by C1 plus 1 by C2. So this becomes D by 2 K1 epsilon naught A plus D by 2 K2 epsilon naught A. So D can be taken common. No, D by 2 epsilon naught A can be taken common. Here this will be left 1 by K1 plus 1 by K2. So you can take the LCM of K1 and K2. D by 2 epsilon naught A is there. Take the LCM of K1, K2. This is left K1, K2. And in the numerator you have K1 plus K2. This is 1 by C equivalent. you have to write the C equivalent. So C equivalent will be 2 epsilon naught A K1 K2 divided by D K1 plus K2. Are you able to identify why are we writing this in series and why are we writing that in parallel? How to write in series or parallel? I'll give you a question right now so that you will try yourself. First note it down, then one question you all will do yourself. Last question for this chapter, for this class also. I'll end the class. But at least try that question. First note it down. If you're having any doubts, we'll discuss. Yes. Did anyone try the question? Any answers? Okay, at least can you tell me how are all the three connected? Are you able to identify this? Akifa, you try?
They are connected in both series and parallel.
Definitely, they are connected in series and parallel. Just tell me which one of them are connected in series, which ones are connected in parallel. Not only series. Yes, say.
K1 and K2, K3 are connected in parallel, and K2 and K3 are divided in series.
K2, K3, these are connected in series or parallel.
Series.
They are connected in series. K2 and K3 are connected in series, and the resultant is connected in parallel.
Yes.
So, yes, Fatima, series K1, K2, then K2 with K1, 2. Fatima Ansari, yes. What's your answer?
Teacher, K2 and K3 are connected in series, and K1 is connected with
The resultant.
K2, 3.
K2, resultant of K2 and K3, yes, correct. See, others who are not able to understand this portion, if you see only this portion, this is which one? What we have done? This one only, distance getting divided. Distance is getting divided, it means they are connected in which manner? Series. So, two capacitors are connected in series. This is C2, C3, and their resultant means this is connected. If you see that at a single capacitor, if you see it as a single dielectric slab, K2, 3, then if you see area is getting divided, means the resultant, both of them are connected in parallel. So they are connected in parallel with what? With C1. This is your circuit. Now writing C1 is easy. C1 is what? This will be K1 epsilon naught A by 2. Area is half D. This is C1. Yes, C1 is K1 epsilon naught A by 2D. Reason epsilon naught A by D is your general formula. K epsilon naught A by D. Fatima Munir, you try for the second one, K2. Just try, I'll help you with it. This is your dielectric slab K2. Area is A by 2. Distance is D by 2. General formula is C is equal to K times epsilon naught A by D. Fatima Munir, try. No answers, Fatima? Kulsum? Can you try, Kulsum? K epsilon naught A by D is the general formula. Here the capacitor, the dielectric slab constant is K2. Distance is D by 2. Area is A by 2. Okay, Fatima has answered. K2 epsilon naught A divided by D2D. Correct. Akifa has also answered. This is 2K2. Akifa, K is also coming. K2 epsilon naught A by D, 2D, I understand. This is you've written for 2. Okay, 2 in the numerator. All right. Anyone else? Okay, write it for C3 as well. C3, all of you. Try it for C3. I'll tell you for C2. So Akifa was right. See, Fatima, this is the general formula. K epsilon naught A by D. K is what? K is K2. Then you have epsilon naught. You have area is A by 2. Distance is D by 2. So 2 gets cancelled. You can write it as K2 epsilon naught A by D only. C3. Okay, so only Akifa has answered. What about others? C3 is easy to write. Yes, yes. Yes, Kulsum, Krishna, good. So Kulsum, now you have understood how to write it? Capacitance? All right. So C3 will be written in this which manner? It will be K3 epsilon naught. Area is half. Distance is also half. So 2 gets cancelled. You get K3 epsilon naught A by D. Now, what are the combinations? C2 and C3 were connected in series. So we'll write it for series C1, 2, 3. This will be equal to 1 by C2 plus 1 by C3. So 1 by C2, 3, this becomes D by K2 epsilon naught A plus D by K3 epsilon naught A. From here, we can take D by epsilon naught A as common. 1 by C2, 3 will be D by epsilon naught A as common. So here it will be left 1 by K2 plus 1 by K3. So if you take the LCM, this becomes D by epsilon naught A. This is K2, K3 by K1 plus K3. So C23 is epsilon naught A, K2, K3, D, K1 plus K3. Now this is not your complete answer. This is not your complete C equivalent. You have to add C1 as well. Why you have to add? Because C23 and C1, these are connected in series now. No, they are connected in parallel. C2 and C3 were connected in series. Now their answer means their resultant is connected in parallel. So you have to simply add it. The C equivalent will be what? C1 plus C23. C1 is what? C1 is K1 epsilon naught A by 2D plus C23 is what? Epsilon naught A, K2, K3, D by K1 plus K3. This is your answer. So in this, if you wish, you can take out common. Epsilon naught A by D can still be common, and then you can take the LCM and multiply, or till you hear you also, you can leave it. Is it clear? Now is this clear? Yes, class, is this clear?
Yes, ma'am.
Yes, teacher.
Hamza, Hanifa, is it clear to you?
Yes, ma'am.
All right, note down this as well. Fatima Ansari, I was asking, did you go through the third chapter, current electricity, till wherever you're coming in your school?
Teacher, not yet, because I have bio exam tomorrow, so I have to prepare for that.
Okay, so at least go through it after your exam tomorrow if you get time. Then if you're having doubts, because till Ohm's law, I think not much portion will be covered then. Ohm's law is in the starting only. So if you have any doubts, then we can arrange a class for you tomorrow. All right, so let me know.
Yeah. Okay, thank you. Teacher, I don't have your number.
Okay. So I'll ask the meeting ID where you get no. The team will contact you. Fine.
Okay, thank you.
Ma'am, it is K2 plus K3 in the denominator, right?
Yes, this is K2. This will be K2. K1 is there. Just make this correction. This is K2. So here it will also be K2. K2 plus K3. Just write done when all of you have written. Done?
Yes, teacher.
Others also?
Yes, ma'am.
All right. So most of you have completed. I hope nobody is writing now. So I'm stopping here today. So this completes your second chapter also. So we'll directly begin with current electricity. So keep on revising chapter number 1 and chapter number 2 now. So all your concepts of chapter 1 and chapter 2, that will be mixed up and utilized in your current electricity. And if go through both of these chapters, you can have Viva any day. So be prepared for both of these chapters and go through them. And if you have any doubts, ask me in the next class. And in the next class, I'll discuss your papers also. We had a test, no? That subjective test. That also I'll discuss. All right. Okay, take care.
Okay. Thank you, ma'am.
Okay.